The Bio-Integrated Future, How Humans, Machines, and Computing Merge in 2025. What if your smartphone was part of your nervous system, or your mind could upload itself to the cloud? Welcome to 2025, where the boundary between human biology and technology is dissolving, giving rise to a bold new world called biointegration. This isn't science fiction anymore, it's the merging of flesh, neurons, and silicon, where technology becomes an extension of our minds and bodies. Let's explore how it's happening, what industries it's transforming, and what it means for the future of humanity. Introduction: Living in a bio-integrated world. Imagine a future where your body heals itself with embedded nanotech, where your thoughts control drones, computers, or even entire smart homes, where AI doesn't just process data, it feels it. This is the dawn of biointegration, the fusion of human biology, artificial intelligence, and computing. A revolution that promises superhuman capabilities and raises profound questions about what it means to be human. What is biointegration? Biointegration means blending biological systems, like your nervous or immune system, with technological devices that live inside the body. Unlike wearables, which you put on, biointegrated tech becomes part of you. It communicates directly with your cells and neurons, extending your capabilities from within. The provocative question: what happens when your body becomes a computer and your mind becomes the operating system? That's where we're heading, toward a world where technology doesn't just assist life, it joins it. From pacemakers to brain chips. A brief history. This revolution has been building for decades. 1980s. The foundations of human-computer interaction, HCI, emerge. 1998. Deep brain stimulation helps Parkinson's patients regain movement. 2018, DARPA funds mind-controlled drone interfaces. 20 Anin Dan. Scientists at Technion develop a bacterial biocomputer. 2025, flexible electronics for health monitoring become mainstream. What began as medical replacement has evolved into human enhancement. We no longer just fix broken systems, we upgrade them. Inside the world of biointegrated devices. So how do these technologies actually work? They use biocompatible materials that merge with human tissues without rejection. Think flexible circuits, soft hydrogels, and neural sensors that communicate directly with your brain. The core components: flexible electronics that bend with your muscles, nanomaterials that conduct energy from your heartbeat, AI algorithms that translate biological signals into digital commands. These devices don't just track your health, they learn from it. Neural implants and BCIs, the mind as a controller. One of the most exciting and controversial breakthroughs is the brain-computer interface, BCI. Neuralink's N1 chip now allows paralyzed individuals to control computers with their thoughts. By October 2025, 12 people had received the implant, 2 of them in the same day. Imagine playing a video game or typing an email, just by thinking. Patients like Noland Arbaugh have already done this. Meanwhile, companies like Synchron are creating stent roads. Neural Divisiber nerding 2. Thus is inserted through blood vessels instead of open surgery. This technology is expanding faster than ever, moving from labs into hospitals, and soon perhaps into everyday life. Epidermal patches and smart biosensors. For those not ready to become cyborgs just yet, smart patches offer a less invasive start. They monitor things like hydration, glucose, and heart rate, all without needles. VTT's patches even track lactate levels for athletes in real time. Quick tips for users. Calibrate your patch daily for accuracy. Use companion apps for insights. Pro tip: start with patches before considering implants. They're a safe introduction to body-integrated tech. Implantable Biosensors, healing from within. Implantable biosensors are changing healthcare forever. Some restore vision using retinal implants that turn light into neural signals. Others manage pain or monitor internal diseases continuously. 2025 breakthrough. Soft, flexible electronics now monitor blood flow and cardiac activity in real time, offering a live feed of your body's inner workings. The rise of biocomputing now. Let's go deeper, to the systems that think like we do. Biocomputing fuses living cells with silicon, creating hybrid computers that learn, adapt, and even self-repair, just like the human brain. How it works: scientists cultivate neurons in lab dishes, linking them to chips that communicate through electrical signals. These mini-brains process data organically, evolving with experience. Breakthroughs in 2025, researchers create biological qubits, turning cells into quantum sensors. Cortical Labs launches CL1, the world's first commercial biocomputer, powered by living neurons. DNA-based processors can now run billions of parallel tasks with minimal energy. This isn't AI pretending to be alive, it's computing that is alive. Neuromorphic technologies, machines that think like us. Neuromorphic computing is another major piece of this puzzle. It's the art of building computers that mimic the brain's neural structure. Chips like Intel's Loihi, IBM's True North, and brain chips Akita don't just calculate, they adapt. In 2025, systems like SynthZulu and SpikerPlus are powering autonomous drones, speech synthesis, and medical diagnostics. Developer insight. Prototype with neural simulation tools like PyTorch before building physical circuits. When biology meets engineering. The fusion doesn't stop with computing. We're now merging biotechnology, nanotech, and genetic engineering to enhance the human body itself. CRISPR editing is rewriting genetic code in real time. Nanorobots deliver medicine directly to cells. Bionic organs, powered by AI, mimic natural function. DNA data storage is replacing hard drives. Pro tip: focus on energy efficiency when building portable bio-devices. Sustainability will decide which technologies scale globally. How bio-integration is transforming industries. Artificial intelligence and robotics biocomputers are redefining AI, making it smarter, faster, and more energy efficient. Neuromorphic processors now power autonomous vehicles that feel the road through real-time adaptive learning. Industry takeaway: integrating bio-AI reduces power consumption by up to 90%, enabling smaller, faster devices. Healthcare and neuroscience. This is perhaps the most profound transformation of all. mRNA vaccines, neuroprosthetics, and AI-driven CRISPR treatments are revolutionizing medicine. Biocomputers model diseases like Alzheimer's with unprecedented accuracy. Patient tips: join clinical trials for personalized medicine. Use encrypted health apps to protect your neural data. Defense and aerospace military and aerospace innovators are using bio-inspired AI for real-time decision-making and adaptive defense. Think drones that learn from experience, or cyber defense systems modeled after the human immune response. Ethical reminder: always integrate oversight mechanisms in military AI systems. Power without ethics is chaos. Energy and chemical engineering biocomputing is optimizing energy grids and chemical simulations. These systems can predict consumption, manage flow, and even develop new materials. Takeaway: construction and manufacturing. Factories and construction sites are becoming self-learning ecosystems. Robots adjust in real time to material feedback. Buildings use self-healing materials that repair micro cracks. Pro tip: combine predictive AI with sensor-based monitoring to cut waste and boost output. Everyday life: how biotech is quietly changing you. Personalized health. Your future health assistant might live inside you. Internal sensors track everything from blood chemistry to emotional stress. They alert you to potential problems before you ever feel sick. Daily routine. Tip: sync internal sensors with wearables for a complete health dashboard. Work, learning, and leisure. Biointegration is changing how we think, work, and create. Neural links boost focus and creative flow. Biofeedback loops train your brain for productivity. Entertainment goes full sensory, with direct brain-to-environment immersion. Future skill. Tip: learn bio-AI and digital ethics now. They'll define the job market of 2030. The ethical labyrinth ahead. As we merge with machines, the question isn't just can we, but should we? Privacy and security. Who controls your neural data? You or the manufacturer? Neural data is the new gold. Protect it like your DNA. Tips: choose encrypted open-source devices. Support neural data protection laws. Equity and access without regulation. Enhancements could create a new class divide. The bio-enhanced versus the bio-normal. Solutions: governments should subsidize essential biotech. Encourage open access research and public funding. Goal: keep the evolution of humanity equitable. What makes us human? As machines become more alive and humans become more machine, the line blurs. If consciousness can exist in code, what does it mean to be alive? Philosophical takeaway: technology should empower, not erase, what makes us human. Empathy, creativity, and choice. The path forward: choice and responsibility. The future of biointegration depends not just on innovation, but on governance, awareness, and ethics. Governments must develop international biotech safety standards. Schools must teach neuroethics alongside computer science. Individuals must stay informed about both the power and the risks. The future belongs not to those who fear machines, but to those who learn to live with them responsibly. The road to 2030 and beyond. By 2030, we may see the first conscious AI hybrids, mind uploads that preserve thought beyond death. Symbiotic intelligence networks linking humans and machines seamlessly. But no matter how advanced the future becomes, one truth remains. We must stay human, even as we evolve beyond humanity. Final thoughts. The bio-integrated era is already here, and it's rewriting the story of evolution itself. We're stepping into a future where humans and machines merge, not as rivals, but as partners in creation. The question isn't when this happens, it's how wisely we choose to live it. SEO keywords: Biointegration 2025, Brain-Computer Interface, Neural Implants, Biocomputing, Neuromorphic Chips, Future Technology, Biotechnology Trends, CRISPR, AI and Biology, Human Enhancement, Bionic Organs. YouTube cross-posting tip: use this article as a voiceover script for a 10-15 minute visual essay. Pair each section with visuals like futuristic neural implants, microscopic neuron networks, biolabs and holographic data overlays, drone control and AI brain simulations. Time-lapse of self-healing materials, add background music that builds awe and curiosity. Think cinematic ambient sci-fi.